Hello mathematicians. So we are starting our new unit on quadratic functions, unit number 7. We are on page 2 and we're starting with day 1, the graph of a quadratic function. So today's vocabulary. Quadratic equations are written as y equals ax squared plus bx plus c and has a highest degree of 2. The graph of this equation is called a parabola, and it's a U shape. Parabolas are functions because they pass the vertical line test, VLT. The axis of symmetry is a line that cuts the shape so that each side is a mirror image. When the shape is folded in half along the axis of symmetry, then the two halves match up. Okay, some things that we could recall that we learned from past lessons and even past courses. So the first thing we're going to do is let's look at number 1. It says, consider the quadratic equation y equals x squared plus 2x minus 8. And it's asking us to graph the equation in letter A. When we're going to graph, the one place we want to go to is, excuse me for my yawning, is we want to go to our calculator, our bestie, to help us best graph. Okay, we're going to y equals. We're going to put in that equation. And we could do two things. We could hit graph to see what it looks like. And then you want to go to second graph to actually use the table to help you actually plot some points. Okay, so I'm looking at it and I'm going to plot some points along here based on the grid that I can use. So if I'm looking at the table and I'm seeing when x is equal to 25, I can't plot x is 25 on the grid that is given to me. So try to stay, when you're looking at the table, stay within the range of the grid that's provided to you. Now, you ladies are working in your notebook, so don't go crazy. I would just stay within like a 10 by 10 frame, okay? So I'm going to plot some points. 0, negative 8. Negative 1, negative 9. I'm sure your points will look prettier than mine. Alright, so those are all the points that I can actually plot on here. And now I'm just going to connect them. I'm actually going to start from this point right here that kind of makes the curve. And I'm going to go up. Oh, I'll do that again. Okay. Now, a few things that we could review here. I'm going to have arrows. All right, they did not give me an interval, so I know I could put my arrows. I'm also going to label. Okay. So those are 2 review items. Now, B. Draw in the line of symmetry. What is the equation? Now, review. The line of symmetry says the line that cuts the shape so that each side is a mirrored image. So basically, I'm cutting this in half. And I notice if I cut this right here, right, and I folded it, I would have the same side. So here's my axis of symmetry line. I'm going to make this a dotted line. Okay, and if we could label it axis of symmetry. Okay, they're asking us, what is its equation? I know it's a vertical line, so thinking of our line types VUX, then I know that the equation is actually going to be x equals, and the x value here, that this is actually cutting on x is equal to -1. Look in letter C is actually a formula that goes along to find the axis of symmetry. So let's see if we use this formula and see if we get the same answer. So the formula is x equals -b, which in this case is 2, divided by 2 times a, which is 1 in this case, and -2 divided by 2 would give us -1. So yes, it is the same. They're also asking us to plot the point of the turning point and label it A. So the turning point is where this graph actually turns, right? So that's actually, oops, I want to change the color. That's actually right here. That's that point right here. I'm going to label that A. And they're asking what's the coordinates. Well, the coordinates for that point is -1, -9. Now, some things we could also annotate on our graph. Remember, these are all annotations, is increasing and decreasing. And if you notice, when we read the graph from left to right, the graph is actually decreasing. Right? And then when after it turns, it is increasing. So just going back to our unit on graphing, we haven't touched upon this since I believe it was unit 3. We talked about graphing linear functions. Okay, so these are all annotations that we should be doing on our graphs. And axis of symmetry, as well as plotting the turning point, is also other annotations we should add when we're working with quadratics. Okay, now looking at letter E. Oh my God. Can't scroll up. Okay, here we go. It says, how does this coordinate, they're talking about the turning point, relate to the equation of the axis of symmetry? How can the axis of symmetry be used to find the turning point? Well, some things that I noticed within the axis of symmetry and the coordinate of the turning point is that the x value is the same. So I would write that the x value of the turning point is the same value of the, I'm going to put AOS for axis of symmetry. I'll make that annotation here too. Is the same value of the axis of symmetry equation. And then this question where it says, how can it be used? Well, if I were to rewrite the equation, y equals x squared plus 2x minus 8, and I replace the x value with -1, So let's do that. I actually would get -9. And if I notice, then this coordinate will actually end up being -1, -9. So I could actually use the axis of symmetry equation, plug it into the quadratic equation, and actually find the turning point. Okay, so another thing says, what are the zeros' roots, and determine them algebraically to see if you get the same. Well, I'm going to scroll down a little bit to answer that question. So here, if we are looking at to find out what are the roots and the zeros, we also know another word for this is x-intercepts. And similar to y-intercepts, where it's when the graph is crossing the y-axis, x-intercepts is where the graph crosses the x-axis. And we notice that in two places, when x is equal to -4 and when x is equal to 2. All right, and I'm just going to label this roots. More annotations to add. All right, let's see if I can go down. Oops. Okay, so we know that the roots here are -4 and 2. Those are horrible. Okay, and similar to what we did in the last unit when we worked backwards, so we would have x is equal to -4 and x is equal to 2. We want to go backwards, and here are, remember, you want them to be equal to 0, so you have to add 4. And here you would subtract 2. So then the factors here become x plus 4 and x minus 2. Just going to label these. Okay, and then if I multiply these two factors, I would end up with x squared plus 2x minus 8 equals 0. Okay, and if you want, I could just show the side work here of how I got that. X plus 4, oops, minus minus 2, and here we would have x times x is x squared, x times 4 is 4x, -2 times x would be -2x, and 4 times -2 would give us -8. Then we combined our like terms. Okay, and then we'll end up with, to show the connection, okay, x squared plus 2x minus 8. Okay, thank you.